Welcome to The Explainer. Today, we're going to figure out what an atom really looks like.
So how do we know what's inside something we can't even see? It's a great question.
Well, it started in the late 1800s. Scientists were studying these weird invisible rays in vacuum tubes.
Turns out, these rays were made of tiny particles, and they all had a negative charge.
J.J. Thomson named them electrons, and get this, they're a fundamental part of all atoms.
This led to the plum pudding model, a ball of positive stuff with electrons stuck inside.
But this simple idea, a groundbreaking experiment, was about to tear that picture apart. Literally.
Enter Ernest Rutherford. He fired tiny positive alpha particles at a super thin sheet of gold. Most particles went right through, but here's the shocker. Some bounced straight back at him.
Rutherford's big idea? The atom's mostly empty space with a tiny, dense positive nucleus at its core.
Okay, but this raised a new puzzle. Why didn't the negative electrons just spiral into the positive nucleus?
The next big clue came from light. See, heated atoms don't glow with a rainbow, but specific colors. This creates a unique atomic fingerprint for each element. We call it an emission spectrum.
Niels Bohr had a revolutionary idea. What if electrons can only exist in specific fixed orbits?
And these electron jumps, they perfectly explain the color fingerprint of hydrogen. It was a huge success.
But Bohr's neat orbits couldn't explain more complex atoms, so science had to get weirder.
And then came Heisenberg's uncertainty principle. You simply can't know an electron's position and velocity.
This completely destroys the idea of a neat, simple orbit. It's replaced by an orbital.
So an orbital isn't a path. It's a 3D cloud showing where an electron probably is.
And these probability clouds have distinct shapes. The simplest one is the s orbital, a perfect sphere.
Then you've got p orbitals that look like dumbbells, oriented in 3 different directions.
And d orbitals have even more intricate, really beautiful shapes. This is the world inside the atom.
So the atom isn't a tiny solar system. It's a nucleus surrounded by these strange probability clouds.
This incredible journey shows how science is always refining our view of reality. So what's next?